All right, so suppose we have a bag with 13 pebbles, 8 are gray, 5 are white, and we select 4 of them at random. So without looking, I just pick 4 completely at randomly. What's the probability that 2 are gray and 2 are white? So the first step to this is understanding what the sample space is and what the outcomes are, right? And then you're all set. So the solution, um, solution, yeah, okay, so the sample space is, let S consist of all choices of pebbles. So not in order. So, and I'm going to put subscripted just to remind you that I really do mean to distinguish between the different pebbles. So if I wrote these out, I could use G for gray. So for an example, so say we would have, here are our pebbles. So would be like G1, G2, G8, W1, W5, like that. So there are 13 of these. And an example, a sample outcome is just any selection of 4 of these would be something like, and I don't care about the order, so I'll use the curly brackets here. So say I have G5, G6, G8, and W4. Okay, so that's just one outcome. Okay. So the reason is you want to set it up so that they're all equally likely. And if I don't put the subscripts, well then I actually don't know. This is what we're really asked, is to compute this probability. With the subscripts though, I know that yeah. So with the subscripts though, I know that anything like this, any subscripted set like this has the same probability of happening. Okay. Now these have to be different. They can't be the same because I'm taking them out and not putting them back. But there's no difference. So this has the same outcome as any other set of 4 pebbles, right? So all outcomes equally likely. Right? So we use the fact that then the probability of E is equal to the number of outcomes in E over the number of outcomes in S, which is in the notes. We talked about this in the lecture. If you're not sure why, you should convince yourself. It's a good exercise to convince yourself. So we want to use this. So what is E here? So we're here in this problem. E is the event. 2 gray and 2 white are selected. So the whole problem becomes a chapter 1 problem. We have to count how many ways I can pick 2 gray and 2 white. So E is just equal to the number of ways to pick 2 gray and 2 white. So this is just equal to 8 choose 2 times 5 choose 2. Since for each, this is principle of counting, this multiplication here. And then for each of the 2 choices here, there are 2 choices here, so I multiply, right? Because if I fix one of the choices here, then I get all 5 choose 2 over here, and then I got to do that for each of them. So I multiply. So this is equal to, quick way to do this, 8 times 7 divided by 2, so I have 28 and 10. So this is 280. And S is just all the way to pick 4 from 13. So this is just 13 times 12 times 11 times 10. And let's see, you can see the 12 goes away there, and I get a 5 here. So this is, let's see, 55 times 13. So 715, I think. And we have P of E is equal to, look, we have 5s going into both of these, right? So this is, well, 280 over 715, whatever that is. Let's see, 56 over, how many times does 5 go in there? Once, 4, 143. All right. Interesting. Okay, so this is the, should really tell you, really the point of this, not so much this number at this point, but the approach, right? We fix the sample space, think about a representative outcome in the sample space, make sure you feel that it is equally likely, that they're all equally likely, and then you can proceed this way by just measuring or counting how many outcomes are in your event and how many outcomes are in the total sample space. Okay, let's do another one. This will probably be have to break this into two different